I woke up this morning and this question came to my mind. From ax squared plus bx plus c equals 0, show that x equals minus b plus or minus square root of b squared minus 4ac over 2a, b alpha plus beta equals minus b over e, and alpha beta equals c over e. And I'm just saying this question, what comes to your mind is that I can't solve this question. But remember, you can't know if you're capable of something until you try. So let's give it a try. From this, we have ax squared plus bx plus c equals 0, which is our quadratic general equation. So it's going to be ax squared plus bx plus c equals 0. Now, for us to get this, we need to apply our completing the square method. Now, the completing the square method is actually a method used in solving quadratic equations, but majority of students, they don't really like it because it is a bit difficult, which is not, if you pay attention to this class. So when we divide through by a, this is going to give us by a. So this is going to be s squared plus b over ax, and this plus c over a equals 0. So the next thing is we take the constant term to the other side. So s squared plus b over ax equals minus c over a. Now followed by the half. What we do is the half of the coefficient of x. This is the coefficient of x. This is not x, this is x squared. So the coefficient of x squared is 1. It's different from the coefficient of x. So the half of the coefficient of x, which is b over a, we do the half, multiply by half. That will give us b over 2a. Then the next thing is we are going to square this, square it. So this squared value, we are going to add it to both sides of the equation. So therefore, s squared plus b a x plus b over 2a all squared equals minus c over a plus b over 2a all squared. Now the next thing is we turn all this to a perfect square. This we turn to x plus b over 2a all squared. I know you are going to be wondering that how did I get x plus b over 2a all squared? Alright, so I'll solve it here for you to understand how I got x over 2 plus b over 2a all squared. So x plus b over 2a all squared, I said I turn this to a perfect square. So equals minus c over a plus b over 2a all squared. So that I'm going to show you how I got x plus b over 2a all squared from this. So if I should take this and expand it, I will surely have this x plus b over 2a all squared. So that is the same thing as x plus b over 2a in bracket of x plus b over 2a. Remember, x squared is the same thing as x bracket x. So if this is x, I'm having it in two places. That's what I did there. So the next thing is, I'll need to expand this. I'll take one of the elements in the first bracket. I'll use it to multiply the second bracket. Is x, open bracket, x plus b over 2a. Then I'll take the second element in the first bracket. I'll use it to multiply the second bracket as well. So plus b over 2a bracket x plus b over 2a. Good. So it's time to expand. X multiplied by x, that will give us x squared. This is not 2x. It is called x squared. X multiplied by b over 2a plus bx over 2a plus the same thing, b over 2a multiplied by x, that will give us bx over 2a. I'm writing bx because I want to arrange it in alphabetical order. Okay, so plus times plus, that's plus b over 2a times b over 2a, that will give us b over 2a squared. You can see this is similar to what we have here. So what I need to get is the remaining ones. I've gotten x squared. So I will simplify this to give me b over a x. So x squared, that will be plus, they have the same denominators. So I can do the LCM to give me 2a. LCM of 2a and 2 is 2a. If I have it here, this is 2a, 2a. A is remain 2. A divided 2a divided by a, that will give us 2. 2, 1, 1. If I multiply them together, 2 times a, that will give me 2a. So the LCM is 2a. 2a into 2a is 1. 1 multiplied by bx, I'm going to have bx plus 2a into a, that's still 1. Multiplied by bx plus b over 2a squared. So this is going to give me x squared plus 2bx, bx plus bx is 2bx over 2a plus b over 2a squared. Now I can simplify. This we cancel this. X squared plus bx over a plus b over 2a squared. So I've gotten what we have here. So that means we can turn this to a perfect square like this. There's no magic there. I turn this back to a perfect square, then I can simplify. So do you understand this? Let's continue. This is actually not a solution for the completing the square. I'm just using it to derive. I'm just using it to derive this perfect square and the expression that we have here. So let's continue with our workings. X squared plus b over ax. Okay, I've turned it to a perfect square. I don't need to rewrite it. That's x plus b over 2a all squared, right? Equals minus c over a plus b over 2a all squared. So we are starting from this point. So the next thing to do is x plus b over 2a all squared equals minus c over a plus b squared over 4a squared. How come? You know it is b over 2a all raised to the power of 2, right? That will give us b squared over 2a squared. Because this squared, the 2 here, the exponent here, is affecting how we have a bracket. So it is going to affect the b and also the 2a. b squared is b squared. 2a squared is same thing as 2a multiplied by 2a. So b squared over 2 times 2, 4. A times a squared. So we are going to have b squared over 4a squared. So that is b squared over 4a squared. So let's continue our journey. Can erase this part? So to continue our journey, we are going to have x plus b over 2a squared equals the LCM of a and 4a squared. Let me write it here. This is a, this is 4a squared. Alright, a in a, that's 1. A in 4a squared, that's 4a. Then a can still divide a, 1, 4, 4, 1, 1. So 4 times a times a, that's 4a squared. Therefore, the LCM is 4a squared. 4a squared. Alright, a in 4a squared, that will give us, you can have that 4a squared divided by a. To cancel one of the a's, you are going to have 4a, right? So 4a multiplied by minus c, that's minus 4ac in alphabetical order. Okay, 4a squared divided by 4a squared, that's 1. 1 times b squared, that's b squared. So the next thing is to rewrite the equation. So I want to have a positive element before the negative element. So it's going to be plus b squared minus 4ac over 4a squared. You see the same thing, I wrote this first before this. Good. So x plus b over 2a all squared equals b squared minus 4ac over 4a squared. Now, I want to isolate x. Therefore, whatever I have with x must surely go to the other side. To cancel this square, because we can't take away this b over 2 without cancelling this square. To cancel the square, I'll do the square root of both sides. The square root of both sides, square we cancel square root. So x plus b over 2a equals, so this I can distribute it under sod. If you have root n over n, it will give us root m over root n. So I can distribute the square root. Therefore, I'm going to have b squared minus 4ac over root 4a squared. So that will give us x plus b over 2a equals, so this is plus or minus, because we are looking for the square root, b squared minus 4ac over, now the square root of 4a squared, the square root of 4a squared is 2a. How you get that? We got it from root 4 times root a squared. We can also distribute this square root. So the square root of 4 is 2. Square root of a squared is a. The answer is 2a. So over 2a. You can see we are almost there. Our quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac over 2a. We've gotten b squared minus 4ac over 2a and the plus and minus. Well, what we need to get is minus b. So to isolate x is going to be x equals, this is positive b over 2a, then to change to negative b over 2a when it comes to the other side, plus or minus square root of b squared minus 4ac over 2a. Now we're almost there. The next thing to do is to look for the LCM. LCM of 2a and 2a will give us 2a. So therefore, what we need to write, we are going to write what we have as numerators. But instead of doing root to the answer, don't let us do root to the answer. 2 into a is 1. That's 1 times minus b plus or minus 2a into a, 1. So 1 times all these as square root of b squared minus 4ac. And that's how to get our quadratic formula. It's as simple as ABC. So the next one is to show that alpha plus beta equals minus b over a and alpha beta equals c over a. Now that we've shown that x equals minus b plus or minus square root of b squared minus 4ac over 2a, which is our quadratic formula, starting from the quadratic general equation, then we need to show that alpha plus beta equals minus b over a and alpha beta equals c over a. One beautiful thing about this kind of question is that your answer, you show if you've gotten it or not. If your answer is not similar to what they asked you to show, then you should know that you need to start all over. Alright, the next one here is show that alpha plus beta equals minus b over a and alpha beta equals c over a. Now before we start solving and getting our answer, getting calculation, remember that discriminant equals b squared minus 4ac. So from this point, which is our quadratic formula, x equals minus b plus or minus square root of b squared minus 4ac over 2a. That means we can write this in two ways. It can be x equals minus b plus root b squared minus 4ac over 2a, or we can write as x equals minus b minus root b squared minus 4ac over 2a. So this is it. Since we have plus or minus, one will work for plus, the other will work for minus. So we can say this is equal to our alpha and this is equal to our beta or beta. Okay, so now that we've gotten alpha and beta here, what we need to do is to show that alpha plus beta equals minus b over a. But remember that discriminant is b squared minus 4ac. So all this, we can write it as d, represent it as d, instead of writing b squared minus 4ac. So we can just write it as d, which is our discriminant. Alright, let's solve it here. Okay, so therefore, alpha will equal to minus b plus root, this is alpha, minus b plus root b squared minus 4ac is our d, so I'll just write d, and over what, 2a, then our beta is going to be minus b minus root d over 2a. It's still the same thing. B squared minus 4ac equals discriminant d. So let's solve for alpha plus beta. So what's our alpha? Minus b plus root d over 2a plus beta, which is going to be minus b minus root d over 2a. So the next thing to do is we need to remove the bracket and simplify. So plus times minus is minus, plus and minus minus, so we are going to have minus b minus root d over 2a. Alright, the next thing is to look for the LCM. The LCM of 2a and 2a, we've done that, is going to give us 2a. 2a into a 1. 1 times that's minus b plus root d, right? This minus here, 2 into a 1, multiplied by all this, b minus root d. So therefore, this equals, we collect like terms, minus b plus root d minus root d over 2a. So therefore, this is going to be minus b, that will give us minus 2b. If you are owing two individuals, 1 naira and 1 naira, if you add the money you are owing together, it's going to be what? 2, which is going to be minus 2. Minus 2b, right? Plus d, root d minus root d, that will give us 0. Just like plus 1 minus 1 equals 0. Good. So we are going to have this, we cancel this, divided by 2a. We are almost there. So therefore, 2 can cancel 2, isn't it? So therefore, alpha plus beta equals minus b over a. Fantastic. So we've gotten our alpha plus beta, which is minus b over a. Now, the next thing to get is alpha beta equals c over a. Alpha beta. Remember that our alpha is minus b plus root d over 2a, and our beta is minus b minus root d over 2a. So for alpha beta, let me write the product. Alpha beta, that's alpha multiplied by beta, is equals minus b plus root d over 2a in bracket, open bracket, minus b minus root d over 2a, close bracket. Now, you see that we are about to expand again. Okay, so alpha beta equals, we take the ones, okay, let me do it this way, so it's going to be very simple. Minus b plus root d, bracket minus b minus root d. I've taken the numerators together. The next thing to take is the denominators. So 2a bracket 2a. And it has been simplified. So alpha beta equals minus times minus, which is plus, b times b, that will give us b squared, minus times minus, that will give us plus, b times root d, that's b root d, good, plus times minus, that will give us minus root d multiplied by b, that's b root d, good. Then the next one is plus times minus, minus root d times root d, that will give us root d squared. If I'm to solve it for students, advanced mathematics students, I don't need to write root d, I'll just write d. There's a reason I'm writing d, but let's do it one after the other. 2a multiplied by 2a, that will give us 4a squared. 2 times 2, 4, a times a, 4a squared. So the next thing to do is to simplify. So from this point, alpha beta equals, so it's going to be b squared plus b root d minus b root d, they will cancel each other. So it's going to be minus square, we cancel what? Square root. So it's going to be bracket d remaining over 4a squared. So therefore, alpha beta equals b squared minus open bracket. Remember that our discriminant equals b squared minus 4ac, right? So let's turn this back to b squared minus 4ac, b squared minus 4ac over 4a squared. So alpha beta equals b squared minus b squared minus and minus plus 4ac, all divided by 4a squared. So the next thing is b alpha beta equals b squared will cancel b squared, right? So we are going to have 4a squared over 4a squared. I mean 4ac over 4a squared. I'm just happy that we're almost there. So this we cancel this, right? A we cancel one of the a's. So alpha, therefore alpha beta equals c over a. Now we've gotten our answer. So I want to use these two methods to solve a quadratic equation. To solve a quadratic equation, so we can know how to apply them and the essence of all these that we've done. So we found that alpha plus beta equals minus b over a and alpha beta equals c over a. Now to the next one, which is solving a real equation with all these methods. So now that we've gotten what they asked us to show, the next thing is I'll be solving two quadratic equations using this formula method and using the sum and product of roots. Good. So for the first one, we have x squared plus 5x plus 6 equals 0. So I will solve this using completing the square. I'm going to solve it using this formula method. Good. So this is x squared plus 5x plus 6 equals 0. And that will give us, using completing the square, we first divide through by the coefficient of x squared, which is 1. So if I divide through by 1, I will still have the same equation. So the next thing is to take the constant term to the other side. X squared plus 5x equals minus 6. Plus 6 return to minus 6. So the next thing is do the half of the coefficient of x. So the half of coefficient of x is 5. So the half, 5 multiplied by half, will give us 5 over 2. Then we square it. So after getting the half, the next thing is we are going to square it. What we have squared, we add it to both sides of the equation. X squared plus 5x plus 5 over 2 squared equals minus 6 plus 5 over 2 all squared. So the next thing is we are going to turn this to a perfect square, just like how we solved using completing the square method to get our quadratic formula. It's going to be x plus 5 over 2 squared. If I expand this, I will surely have what we have here equals minus 6 plus the square of 5 is 25. The square of 2 is 4. So therefore, x plus 5 over 2 all squared equals, the LCM is 4 plus 6 over 1, and then we have 4 here. So 1 in 4 is 4. 4 times 6, that's minus 24, plus 4 in 4, 1. 1 times 25, that's 25. So what we have is x plus 5 over 2 all squared equals minus 24 plus 25 is the same thing as 25 minus 24, which gives us 1 over 4. So let me write this. I'm going to have x plus 5 over 2 all squared equals 1 over 4. So in order to isolate x, I need to cancel the square root, the square. So I'll do the square root of both sides. Square cancel square root. X plus 5 over 2 equals 1 over 2. The square root of 1 is 1. The square root of 4 is 2. And we are going to have plus or minus because we've introduced the square root. So this is going to be x equals, I will take this to the other side, that's minus 5 over 2 plus or minus 1 over 2. Therefore, what we are going to have is x equals, the LCM of this is, okay, or instead of doing that, we can just take the ones with plus and the ones with minus. Minus 5 over 2 plus 1 over 2, or x equals minus 5 over 2 minus 1 over 2. So x equals, this LCM of 2 and 2 is 2. So that will still give us minus 5 plus 1, or x equals 2, and that will still give us minus 5 minus 1. Therefore, x equals minus 5 plus 1. That will give us minus 4 over 2, or x equals minus 6 over 2. Therefore, x equals minus 2, or x equals minus 3. These are the values of x. Now, we can show if our answer is correct or not. From this equation, if we substitute the value of x equals minus 2 here, it should give us 0. And if we substitute the value of x equals minus 3 here, it should also give us 0. So to check, we have x squared plus 5x plus 6 equals 0. So when x equals minus 2, so it's going to be minus 2 squared plus 5 brackets minus 2, 5 bracket minus 2 plus 6 equals what? Minus 2 squared will give us 4, plus and minus, that's minus, 5 times 2, 10, plus 6 equals, what is it going to give us? 4 minus 6, minus 10, that's 6, minus 6, minus 6 plus 6, that will give us 0. So this shows that x equals minus 2 satisfies the equation. Now what of when x equals minus 3? Let's try that also. It's going to be minus 3 squared plus 5 bracket minus 3 plus 6. We want to check if it's going to give us 0. Minus 3 times minus 3, that's plus 9. Minus, plus and minus, minus. 5 times 3, 15, plus 6. 9 minus 15, that is minus 6. Minus 6 plus 6, the answer equals 0. So it is showing that both x equals minus 2 or x equals minus 3 are satisfying this quadratic equation. This is how to use the completing the square method to solve a quadratic equation. Now to the next question. 2x squared plus 9x equals 5. Now in most cases, they will give you in this form, but in some cases, they will want you to rearrange the equation. So don't be tempted to start solving and solving. Good. We can actually leave this way because we are still going to take the constant term to the other side. But if you are solving for a quadratic equation using factorization method, you need to take it to the other side so you can be able to factorize. But let me first take it to the other side to get our quadratic equation. So because quadratic equation is equation in this form, ax squared plus bx plus c equals 0. So 2x squared plus 9x minus 5 equals 0. So the first thing is we divide through by the coefficient of x squared. So we divide through by 2, 2, 2. So therefore we have x squared plus 9 over 2x minus 5 over 2 equals 0. So the next thing is we take the constant term to the other side. So x squared plus 9x over 2 equals 5 over 2. No, it is negative 5 over 2. So they change to positive 5 over 2. Therefore, we do the half of the coefficient of x, which is 9 over 2. 9 over 2 is the coefficient of x. Therefore, we do the half, multiply by half. That will give us 9 over 4. Then we square it. So after squaring it, we add it to both sides of the equation. So this is going to be x squared plus 9x over 2 plus 9 over 4 all squared equals 5 over 2 plus 9 over 4 all squared. So we've added it to both sides of the equation. The next thing is to turn it to a perfect square. The next thing is to turn this to a perfect square. We are going to have x plus 9 over 4 all squared equals 5 over 2 plus 9 squared will give us 81 over 4 squared will give us 16. Now, feel free to pause the video and try to expand this. You will surely get this answer. So, is x plus 9 over 4 all squared equals 16. That's the LCM. 2 in 16 is 8. 8 times 5, 40. Plus 16 in 16, that's 1. 1 times 81, 81. The next thing is x plus 9 over 4 all squared equals 121 over 16. So to cancel this square, in order to isolate x, you square root both sides, plus or minus. So it's going to give us square cancel square root, x plus 9 over 4 equals plus or minus. The square root of 121 is 11. Square root of 16 is 4. Good. Because 11 multiplied by 11 equals 1 to 1. Just write 1, 1, 1 plus 1, that equals 2. Good. So that's 1 to 1. Then plus or minus 11 over 4. The next thing is to collect like terms. X equals minus 9 over 4 plus or minus 11 over 4. So x equals the LCM, or we take it one after the other, that's minus 9 over 4 plus 11 over 4, or x equals minus 9 over 4 minus 11 over 4. So x equals, the square root is 4 and LCM is 4. That will give us minus 9 plus 11, or x equals 4. This is going to be minus 20, yes, over 4. Minus 9 minus 11, that's minus 20. X equals, this will give us 9, that's minus, okay, plus 2 over 4. Plus 11 is greater than 9. That's the same as 11 minus 9. Or x equals minus 20 over 4. So our final answer, x equals 1 over 2, or x equals minus 5. Now, feel free to pause the video and substitute the value of x into this equation. Right. So the next thing is to solve for alpha plus beta equals minus b over a and alpha beta equals c over e. But before we do that, I want us to also use this formula method, quadratic formula, to get the same answer. Because what we just applied in completing the square method. Right now, I'll be solving these two questions using the formula method. The first is x squared plus 5x plus 6 equals 0. But you can see that in our quadratic formula, we have b, we have a, we have c. How can we get that? We equate this to our general formula, which is ax squared plus bx plus c equals 0. Therefore, our a here is the coefficient of x squared, which is 1. Our b here is 5. And our c is 6. So after getting this, the next thing is to substitute it into the quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac over 2a. So x equals minus b is 5, right? Plus or minus square root of b squared, that will be 5 squared, right? Minus 4 bracket a, 1, bracket c, 6, over 2 bracket 1. Therefore, x equals minus b plus or minus square root of 5 squared is 25, minus 4 times 1, 4, multiplied by 6, that's 24, divided by 2. So let's continue our journey. X equals minus 5 plus or minus square root of 25 minus 24, that is 1, over 2. So x equals minus 5 plus or minus square root of 1 is 1 divided by 2. Now I can write this in two ways. I can write as x equals minus 5 plus 1 over 2, taking the positive sign, or x equals minus 5 minus 1 over 2, taking the negative sign. So therefore, x equals minus 5 plus 1, that's minus 4 over 2, or x equals minus 6 over 2. Minus 5 minus 1 is minus 6. You are owing two individuals money. If this is 5 naira and this is 1 naira, so if you add the money you are owing together, it's going to be minus 6 naira. So 2x equals minus 2, or x equals minus 3. You can see it is very, or let's say the same thing as what we got using our completing the square method. So let's use that to solve the second question, number 2, which is 2x squared plus 9x equals 5. Remember, we rearranged it. So 2x squared plus 9x minus 5 equals 0. So equating it to our general formula, we have good. So here you need to be very careful because you are seeing a negative sign. That negative sign is something that can destroy someone's calculation if you are not very careful. So a equals 2, b equals 9, right? And c equals minus 5. Good. So we've gotten a, b, c. Let's write our quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac over 2a. So x equals minus b, that's minus 9, plus or minus square root of 9 squared minus 4 bracket 2 bracket minus 5 over 2 bracket 2. Remember, our a is 2, our b is 9, and c is minus 5. So to continue here, we are going to have x equals minus 9 plus or minus square root of 81 minus, okay, minus times minus, that will give us plus, isn't it? So 4 times 2, 8, 8 times 5, that's 40, divided by 2 times 2, that's 4. So x equals minus 9 plus or minus square root of 121 over 4. So x equals minus 9 plus or minus square root of 121 is 11 divided by 4. So I can write this in two ways also. I can say x equals minus 9 plus 11 over 4, or x equals minus 9 minus 11 over 4. So x equals minus 9 plus 11, that will give us 2 over 4, or x equals minus 9 minus 11, that's minus 20 over 4. So x equals 1 over 2, or x equals minus 5. You can see it is the same as what we got using the completing the square method. So we've solved these questions using quadratic formula and completing the square. And the next thing to do is going to be the sum and product of roots, which is alpha plus beta equals b over a, alpha beta equals c over a. We still have others, alpha squared plus beta squared, which will give us alpha plus beta all squared minus 2 alpha beta. But for now, let's just solve this using our quadratic formula. For the sum and product of roots, we have x squared plus 5x plus 6 equals 0. This is the sum and product. Okay, for the sum and product of roots, x squared plus 5x plus 6 equals 0. So how can we solve this? We have alpha plus beta equals minus b over a and alpha beta equals c over a. Okay, let's compare with our quadratic general equation. Okay, our a here is 1, right? B is 5 and c equals 6. Therefore, for alpha plus beta, it is going to be minus b over a. And what is our b? That's minus 5 over a, which is 1. The answer is minus 5 over 1. Therefore, alpha plus beta equals minus 5. For alpha beta, which is c over a, that will give us c over a. What is c over a? C over a is 6 over 1. Therefore, it is equal to 6. So therefore, the sum of roots equals minus 5, and the product of roots equals 6. So in our next class, I will be solving quadratic equation using factorization method and as well graphical method. Also, I will be solving the sum and product of roots. I'll be solving more advanced questions, more complex questions like alpha square plus beta square, alpha over beta plus beta over alpha, 1 over alpha plus 1 over beta, and also alpha cube plus beta cube, and the rest. So make sure you subscribe to my YouTube channel so you can enjoy all these benefits. Remember, the only thing you are going to pay in this class is your attention. So, thanks for watching. Once again, my name is Professor Black.